Then welcome to my presentation, EOQ, an open source interface for a more DAMM domain-specific model utilization. My name is Bjoern Annighoefer. I'm here from the University of Stuttgart and the Institute of Aircraft Systems. So first of all, I don't want to use any swear words here. So DAMM, as used in the title, does stand for Determinism, Automation, Multi-Element, Multi-Model, Multi-Computer, Multi-User, and Neutrality. Properties that we think are important when using domain-specific models in such distributed digital processes as we have seen them today. So, and then there was a second abbreviation in the title, EOQ, that stands for Essential Object Query, and that's basically a interaction language or generic interface for domain-specific models I will present today as well. So as a motivation, I give you a brief view on the world I'm doing research in for more than 10 years now. We are an institute that is focused on avionics systems, so computers flying in aircraft. And current avionics systems are shared distributed computing platforms, and there are many stakeholders involved in developing such systems. For example, the system functions hosted on this distributed platform are developed by several engineers. There are system designers, requirements engineers. Also, CAD engineers are partially involved, and modules need to be configured or tested. And the final result is, at least in my perspective today, the load loaded later on as a software load on the computers flying in the aircraft. Okay, what I imagine is a so-called digital avionics development process. I think that can be applied to several industrial domains where you would like to have a digital process. What do I mean by digital? First of all, I assume the prerequisite that everybody here is working with formally specified models. I would prefer so-called domain-specific models. I know that's not the case today, but this is the prerequisite. In addition, I would assume that the common information within all those development artifacts are digitally linked. So if I change something here in my system application, for example, I need an additional interface, this is automatically propagated into the system design, the requirements, the wiring diagram, and also into the configuration. So we can establish something like that with model repositories or model databases. There are several solutions available. We have seen quite some solutions today, but still I'm feeling that what I imagine here is not, I would say, completely sophisticatedly implementable with the existing solution. There are some reasons. I would prefer if this collaboration here, the digital process, would work in real time. So imagine it a bit like Google Docs for avionics system development. Here I see some lag. I see that if you use any implementation here, you are quite bound to a platform-specific interface like Java or something. Automations that just popped up before. I think automations are algorithms that are not bound to any of those specific tools, but are bound to the data you are working with in such a way that everybody can use this automation. So an automation could be, for example, an automatic signal routing within your given avionics architecture. Okay, and what else I have seen quite a lot of times is that people export the model-based data, if they have some, to Excel, then work in Excel and later on re-import. And one of the reasons I think is causing this is that the mass data manipulation of current interface to such model databases are not very good. Okay, one thing I will not address here, actually for me the holy grail would be if I can achieve all this here as a digital process. And in addition, we can also derive so-called qualified artifacts from the model. So in this case, the load that is later on flying needs certification, and usually that is done by manual verification and a lot of tests. If all this digital process here would be a qualified toolchain, then you can skip quite a lot of the final effort here for certifying this. Okay, so these deficiencies are quite subjective, and then this brings us to the DAMM qualities. And here we tried to characterize more objectively what really is necessary to enable such a digital process. You remember the criteria from the DAMMMMN abbreviation, and for each we specified some subpoints. Like for determinism, we want that the same input results in the same output, that we preserve the element order, something that maybe is not always the case in EMF, for example, and that any interaction with our model elements happens in finite time. This is an example that is, I see, not fulfilled with any of the existing frameworks. Okay, to make it short here, I only have 15 minutes. There are quite some solutions. So EMF Store and CEO were some early frameworks that enabled shared usage and working with domain-specific models. Magic Draw has also a collaborative solution. Then there are, I would say, proprietary meta models in A2MPM or WebGME. They have a browser-based interface, can work with multiple people. And maybe the solution which fulfills most of our requirements, but not all, is the ecosystem around inquiry, Viatra, and Epsilon. And there are many other solutions, and the conclusion here is that you will find a fulfillment of each of the DAMMMMN qualities here by the tools, but not a perfect coverage. So in one gray row here, which is not further discussed, tool qualification which would be needed in case you would like to create certified artifacts is not in scope of any of those frameworks, and caused by the implementation they are using and the programming languages, I would say it's infeasible for all of them. Okay, let's continue with the essential object query. What is that? The idea is quite simple. When we have this digital process, you have a set of meta models that define your domain-specific or user models here, and you have several of them. One meta model for each of the development artifacts. On the other side, you have all your stakeholders and the software they are using, or they even interact manually with the data. And the idea of EOQ is just very simple. It's just a generic interface between your model repository and all your stakeholders. And it enables reading and writing the data. It even simplifies reading and writing, helps you to synchronize all the modifications in your data, and also acts like a guard that protects element from being accessed or modified when you don't have the sufficient rights for that. So that shall be a standardized interface in between. Let's do that by example. Here you find an excerpt of an avionics architecture model, just very simple. And within this model, you find, for example, elements of type device, of class device, elements of type connections, and also device types. And this model is now guarded by a so-called domain, which is the, I would say, gatekeeper in EOQ to any model data. So, and our task is to rename all devices to new name where the type is named RDC. So here are two devices, and here is the type, and this type here is called RDC. So this would be a so-called set command in EOQ, which takes three arguments. First, the target element, so what element needs to be modified, then the name of the property to be changed, and the new value. All of the arguments can be so-called queries, and because this is quite powerful, this query here is the name provider for our essential object query. Okay, in case of this second and third argument, it's not really a query, it's just a string because it's quite simple. So the attribute is name and the new value is new name. But in case of the target, here a query is specified, which reads as, please select all elements of type device, and then further look into the reference type and the attribute name, and look if it equals RDC, which stands for Remote Data Concentrator, by the way. So this is taken by the domain. It will find those two elements here, both linked to the type RDC, change the name, and will reply everything has worked successfully. In addition, each change to the model will cause an event, which is then propagated to all observers, which could be other tools. And it will include a reference to the element changed, the property that was changed, the new value, and also the old value. And in addition, what I have not told so far is that each transaction, so every command that you issue, and you can also bundle several commands to one transaction, is assigned a unique and increasing transaction ID. And every change that is created by commands, every atomic change also gets an unique and increasing change ID, which makes all the interaction very traceable. Okay, so what I have written here is the so-called text form of EOQ, and you see it's fully text serializable. It's quite compact, and if you have some training, it's quite easy to read what shall happen. In addition, strings are supported by any programming language, so it's quite portable. So even more, we on purpose created EOQ such that in no case any objects are transmitted, only unique IDs of objects. First of all, that shall prevent any side effects, that a client changes object properties and doesn't synchronize that back to the domain. And second, on the client side, we don't need any object-oriented language. It can be done also in C and Ada, which are languages that are, I would say, quite important still in our domain. So a short summary on what is possible with our interface. We have commands and we have queries. Commands are the first point of interaction. They can be used for reading and writing your data and also for managing the domain behavior. There are get and set commands, delete, but also more complex commands like cloning a subtree of a model. In total, we have 28 today. Queries cannot be used standalone, but only as arguments for commands. Queries are read-only, so they can only retrieve information, can be used for composing information or filter information, but will have never side effects, or modified model data cannot happen from queries. So here we can refer to an object by ID. We can also navigate the path within the model. We can select elements of a certain type, but even more complicated things like try and accept statements are possible. So in total, 31 are available currently. I must say here that all the commands and queries that we implemented are derived purely from the practical usage of our domain-specific models. So we implemented those commands and queries which allowed us to work most efficient. And this is still evolving, so it might change in future. We might remove some because they are not frequently used, and might add some others that are even more useful. Okay, I also would like to do a short demonstration. Before that, I would like to mention that EOQ is intended to be completely open source, so you can contribute to that or try it. Just follow the link here. What we did is we created a reference implementation based on Python. And I will use this today. So you see the window of a so-called EOQ domain WebSocket server running in Python. This just provides a WebSocket interface where you can enter those textual EOQ commands, work on your data, and will get the result. So what we connect here is just a very basic browser-based console where we can just by typing issue those commands. And in the backend, we are currently fully compatible to the Eclipse EMF eCore standard. So we can read eCore meter models and the user models that are based on these meter models. And just for demonstration purpose, I will show here a model opened in the Eclipse generated model editor, but this is not mandatory. It's just for showing you what happens. So the example we are doing is the example from the paper, but just partially. So in the paper, we use an example called Arc Designer, which is a hypothetic tool for designing avionics architectures, so distributed computing architectures. You can create devices, signals, connections. You can even route signals on connections and devices. And here I will skip the part that creates the meter model. So you can use EOQ also for creating meter models. I will also skip the part that initializes the user model, and will start with adding some content to the user model. And that will happen in the demo. And last thing will be that within the demo, we will also call an automation that automatically calculates and signal routing. So let's play the video. So we start with an empty root node in our user model. Just because Eclipse is rather slow in updating, I will show all the updates in a text editor. So first thing is we get the root node, which is #4 here. And this is a node where we make all our changes to. So next command will add 2 tasks just in one transaction, and also specify the name. Then we will add a new signal between those 2 tasks, also in one transaction. If this transaction fails, the signal will not be created, and also the property changes will not happen. Then we add 4 devices. So here's just a graphical representation of the model, how it currently looks like. Then it will add 4 connections between the 4 devices. Here it becomes slightly more complicated. And then finally we assign the 2 tasks, one to device number 1 and one to device number 4. And now we would like to have a route for signal 1, 2. First of all, here it enables the observing of any events, because the routing action will be called asynchronously and will send events on any changes. And there's an auto routing action. The implementation can be found in the paper, and this will now calculate a route which correctly puts the signal here on this route. And we can also retrieve the route, which is maybe a more interesting query here, which uses a try segment, just to give you all the elements of the route by name. And finally, you can also see in the Eclipse editor that the segments have been successfully added. Unfortunately, the property view is hidden here, but you will find the same information as shown in the text editor. Okay. Having said that, let's make a short conclusion. I started with the DAMM qualities, where we were not fine with the existing solutions. I must confess here that with the current stage of EOQ, I'm still not fine. So you see here that the compliance check marks are almost the same as for the best feasible solution inquiry Viata. There are some shifts. For example, the point of automation here is fully covered, but others are not. The problems that we still have is, for example, the finite time. We can't ensure that currently for operations. We also have a problem in splitting our database to multiple computers. And we have not implemented so far, at least not released so far, an object-level access control on the model-based data. And finally, we are still, and you can see that in the paper, we are still dependent even, or at least if when we create the meter model, on some specifics of the eCore meter model. But also that needs to be removed in future. So the difference here is that for all the deficiencies that we still have with our current implementation, we see a way forward to be fully compliant to our DAMM qualities. And even for the tool qualification, I have a short teaser for you. We think that it's possible to implement this EOQ interface and also the runtime for the domain-specific model repository in a at least qualifiable way. And the teaser just follows. So here's the screencast from an domain-specific model runtime based on Ada and Spark. Ada is a programming language resulting from safety critical software development, and Spark is a formal verification addition to that. And this looks quite cryptic, but if you take some time, you will notice that what happens is just the basic creation of a very small meter model. So if you are interested in that, you will find 2 papers on the model's main track. Here are the references, and we think that we can extend that later on to having a fully qualified implementation of our model repository. So thank you for your patience. If you have any questions, I'm happy to answer. And if you like to see EOQ or contribute to that, please find the link here. Thanks.
Okay, thank you very much. And I'm still digesting what I saw. I mean, I have a couple of maybe comments and questions. I mean, one is what we see in our environment is that adoption of anything that is somehow related to, well, within the Jupyter environment is much easier. So I wonder, because it's you're Python based, you said, I think, and in our case, we have more than 600 Jupyter users in our environment, in our engineering environment. Do you think there is a way to make that available like in the Jupyter environment instead of generating from Eclipse?
I must confess here, I have zero knowledge on Jupyter.
Okay, good.
Actually,
okay.
Our purpose is to have the interface to the domain-specific data as simple as possible, and therefore I'm quite sure that Jupyter can be extended to retrieve data via the EOQ interface. I don't.
Yeah, I mean that's what we have. I mean, like querying or authoring data. I mean, we do through Jupyter notebooks, for example, also with inquiry. So I think EOQ should be should be a similar case. The second question maybe is, or a comment is, because you have this on the one of the first slide, you have this linking between all the stages of the development life cycle, and I think probably some of your requirements or experience could be probably valuable in developing or in the development or architecture of the next generation of MMS and Open MBE, because there the vision is that MMS is the authoritative source of all the cross references. So I kind of see somehow maybe an opportunity there that we could follow up offline.
Okay, I'm happy to help and also to get more knowledge on MBEE and the contributors. You see, I'm from the academic world here, so
no, that's good. That's why
I cannot provide the end depth
to create this connection. I think that's the main purpose here.
Okay.
Okay, cool. Any other questions?